Shall we? 8 minutes late? Can we? I think we go. You start, I start.
The end is near, and to every end there's a beginning, and that also applies to the network. I think we have had a great, wonderful network, and Maxim Salomon, Niels Bakker, and Elisa Jasinski will tell you more.
Thank you.
Okay. This is Maxim, this is Niels, I'm Elisa, and we're going to... It's okay? So we're going to present what we did for the network planning and design, and in the end rolling out all the stuff here on the campsite, and how that went, and what we experienced in the past couple of weeks while doing that. So let's start out with some numbers and some stuff we used here on this field. We stole some fiber from previous events. The gray fiber was used at Hull a couple of years ago. The black fiber is from What the Hack, so they had spares. And we had in total about 4 kilometers of fiber that we rolled out on this field. We got a lot of help from volunteers that arrived earlier, digging in the stuff in between tents, because yeah? Yeah? Besser? Okay. Ist an? Ist besser? Gut, dann nehme ich den. So yeah, a lot of digging was involved, and it was difficult to put all in so we can like protect the fiber and take care of, well, not destroying only uplink we have to this campsite and cutting everybody off from the internet out there and things like that. So also, because we had like huge rolls of fiber, we had Starbuck helping us with splicing connectors to it. It was quite some work. It took a couple of days in the end to finish everything with his. Well, he took his stuff from work or somewhere, I guess. So he was sitting there on the field, basically everywhere where we needed to splice something after the fiber was already in the ground, and putting connectors on it. And the first rough idea, I mean, of course you sit down up front and you think about what would we like to do or what would we like to have, but you haven't been here before. Well, we saw the campsite before and we had a rough idea of how the area looks like, but you never know where people are going to stay in the end, or where people are going to put their tents, or where a lot of stuff is going to happen. So a first rough plan was made somewhere beginning this summer, and it looked like that. So it was basically a drawing on paper, that's a scan, and well, we have some things that differ from this first idea right now. We will see another plan later on that actually shows what happened on this field, but just to see, like, that was the first idea we had of putting internet on this campsite. To connect everybody and to place switches somewhere in the field, we need something like, well, something to put them in. So there is already the known great facility, network facility of a Datenklo, where well, we can put in the switches. They stay dry in there. They're waterproofed, so it's not getting too hot. At least everything was pretty okay with the temperature in there so far. So when we arrived here, the first thing we basically had to do was to lock up the clothes, because after they were standing in a row at the entrance. Some museum visitor already mistook them as a real claw, and before we had the chance to put the lock on it, so we locked them up so that people actually know that it's not a toilet. And we started building some stuff. Bram helped us to get like some wood inside so we can actually place the switch somewhere and not on the toilet seat and things like that. Well, and then we were basically walking around the campsite looking like, okay, which area is nice and where should we put a toilet? And, well, moving them happened with this truck thingy. So we placed in total about 17 data toilets on the whole campground in various areas. And connected them, most of them with the fibers before. So, and then besides all the things that we have on the campsite, actually, we had the uplink fiber, and the uplink fiber is our one and only connection to the outside world from this ground, because there is not really a huge demand on bandwidth on this airfield normally. So we talked to a lot of people up front, and the local companies and some other companies made it possible to get like this single mode fiber relayed from the next pop in Fino, which is 3.5 kilometers to the west side, to where the NOC trailer is standing right now next to this shelter. It's going like it's going basically over the grass everywhere, so we dug in most of it on this camp field as well, and then it follows a road for a while. And in the beginning we were worried about, well, there's apparently there's an issue here with copper theft, and people might mistake that for a copper cable and cut off parts of it or something, but it basically is still there and it's still running as far as I know, so that went pretty well. That is the path where it's actually going. So we start here at the 2 bunkers and the NOC trailer on the left side, and it's going over the whole airfield, somewhere through some woods, ending up in Fino up there. So this fiber was put in place by Telta, the local internet provider here in the area, and so we could pretty much start from like the end point already having a connection here on the airfield. So in the end, after being here and considering everything and having the data toilets ready, we put everything in place, and in the end it looked like this. We did not, for example, we didn't know that in the beginning that, well, quite a lot of people will show up here, so this whole area on the bottom wasn't planned to be a camping area, and we had to expand that day by day. The last switch over here we put in there yesterday, or 2 days ago, just in case somebody might want to connect there already. And another thing was the west end on that side. It looked like a wood from like the maps and seeing it on a plan for the first time, but once we walked there it looked like a really nice wood with spots in between the trees actually to put the tents. So okay, we had to drive somewhere with the Datenklo inside the wood so that people can connect there as well, and it ended up being like this. Well, okay, and of course it's not enough to have a lot of fiber and a lot of toilets. We have to have some stuff to put inside there. So here's a long list of, well, some hardware we got from companies, sponsors, individuals that just brought stuff along they have spare or don't need, or, well, I'm not going to name that all now, it is quite something. And next to that, to like build the network, we also need to provide at least some services. So we had a couple of servers to run DHCP, DNS, and everything that is like needed next to a network here. So the hardware arrived here like on the first day when we actually started building.
Thought you were good photos.
The hardware started showing up here, I think, 1.5 weeks ago. So we basically had 1.5 weeks to set everything up and also place the fiber and do everything on this campsite. So we started out with unpacking everything and stacking it and see what we actually have and what we got, because in the end you never know what a company will have spare, and you never really have this fixed picture of we are going to get this and that. Something's changed, somebody's bringing more or less or something, somebody forgot about something, so you have to rearrange quite some stuff or arrange something in the last second to actually be able to use it as planned. So we started puzzling around what we can do with this stuff, and you might have seen this white trailer next to the shelter here. This trailer was on This trailer was on the campsite before, and well, somebody told us we can use it for being like a co-location or something like that. So we placed it pretty much in the center to have, well, a good way to put our core somewhere and to run fibers from there to everywhere else. It used to have an air conditioning inside, but it's like really old, and we did not, well, I think we did try to actually run it, but it didn't work. So we had a couple of air conditionings in there, and there were like holes already on one side, so we had a place to run all the fibers out of the trailer and out of our data room inside there. We got a rack, fortunately, from somebody. So inside this we had a rack. Okay, so guess what? Left is before and right is after.
Right is now.
Right is now, exactly. Well, for the next hour or something. So yeah, we got this rack, so we don't have to put like everything on tables, and it was quite nice to could stack things on top of each other. What happened to the Cisco and Foundry with the fans? I think it was something that like the Foundry was on top of the Cisco in the rack in the first place, and the Cisco blows the air out there where the Cisco sucks it in again, and we had some heating issues, so we had to rearrange that as well. I think these things are not really built to be in a rack next to each other or something. But
or we mounted it the wrong way around or something.
Or we mounted it the wrong way around, exactly. You never know. Okay, so that was the main core in this white trailer standing next to the shelter. We had a couple of, well, sort of bigger pubs connected on the campsite with 10 gig connections. One of them was the hack center, and like 2 or 3 more toilets that were pretty much distributing stuff further. So one toilet on the south side, on the south camping side, was with 10 gig, and from there we could fan out to 2 smaller access switches. So that was the switch we had in the hack center to connect the whole west side and everybody in the hack center. And okay, oh yeah, and talking about the cooling problems. So I think first we had 1 air conditioning in there. Then we got 2 spare ones, and with 3 air conditioning we had still like 60 degrees at some point in this trailer. So we ran to the hardware store and got a 4th one, which was a bit more powerful than the first 3. Actually, the 4th one was as powerful as the first 3 together. So in the end, we ended up having 4 air conditionings going out of this trailer like that, and it was quite okay at the end.
Okay.
Still warm. Okay. Does that work? Or?
Does this work now? All right. So I'll talk a little bit about the actual network layout. This is the drawing of the final layout as it actually was out on the field. In the center, there's a core router. It's the Foundry MLX that you saw a few slides ago. It's a combined switch router type deal, so it can both switch on ports and switch traffic, and it can route as well. To that router were connected all the switches in the datum close. We ran VLAN tagging to over all the links. We ran VLAN tagging over all the links to the datum close. These bold ones were the bigger ones that we used as distribution switches with more switches attached to them. So I think this was camping 2, and there was a whole bunch of switches hanging attached to that for further distribution out on the south camping field. We had a server park here. We had one router on site to take care of the uplink, and we had another one here in Berlin to take care of more peering and transit there. So in the end, we had quite some address space available, luckily, so we could be a bit creative in assigning subnets, in assigning VLAN tags. So we decided upon a system where we would make a correspondence between the VLAN tag, the router interface, and the IP subnet actually in use. So if you had an IP address somewhere, so somebody came and said, oh, there's a problem with this IP address, I can't get DHCP there or something, then you immediately knew it was this router interface, it was this VLAN tag, and this is the IP address of the switch that handles the distribution there. And that was a great time saver, because you don't always have to go back to some sort of wiki that is usually outdated, or some sort of having to trail through various config files to find that information. So some various traffic statistics. The west, behind the hack center camping place, 800 megabits peak. It's quite well. Villages in the southeast, Freifunk, others, 850 megabits. Gigabit to south camping, well done. You made the 10 gig we run there worth it. And Audio Village was another big one. The streaming guys, basically. 140 megabits to wireless, which I think is sort of comparable to what we did at the Congress. And the Projektleitung was also very active in the last 2 days, speaking to 600 kilobits per second. I think they were busy doing press interviews or something. So I'll spend a few more words on design and issues you run into when you try to do such sort of thing. Our objective was to bring Ethernet to all the people around here, all over the campsite, and have that up and running as much as possible. We decided to use lots of subnetting, lots of VLANs, and decided to use that over one big VLAN where everybody would be in, because you can easily localize local issues. You can keep a network loop very local. You can keep a rogue DHCP server very local. And if there's a problem on one particular subnet because there's a loop on the Ethernet, there is a rogue DHCP server, or somebody sending rogue IPv6 router advertisements, or whatever, ARP spoofing, MAC flooding. It's all very localized. It just impacts one switch or 2 switches and whoever just happens to be there. And you can easily locate it, isolate it, and tell those people to stop, basically. The predictability of router interfaces versus VLAN tags and IP subnets was a very big time saver. So the IP subnet with 81.163.24 would probably be a /23. It would have router interface 24, it would have VLAN tag 224, and the IP address of the switch would also end in .24. So it is all very easy to find your way through the network without actually having to memorize large tables with randomly allocated IP addresses handed out in order of time. Redundancy generally adds complexity, and we don't have a 100% uptime guarantee SLA thing going on here. It's nice, but at some point you have to say, this is too much effort to put into something fragile. It's more likely to actually fall over because of all the redundancy you put in. Ethernet isn't really isn't really built for redundancy. You have spanning tree, which is a crappy protocol. It always goes flapping, and then you have more outages. A lot of issues there you can run into. If you just run a single fiber somewhere with the backup of being able to splice different connectors on different strands in a multi-core fiber, then you don't lose much in redundancy, but you gain a whole lot in simplicity of installation. The same with servers. You can set up all sorts of very nice load balancing tricks with Linux and VRP and redundancy, but in the end, then you run into all sorts of weird issues with ARP resolution not working. It just wastes a lot of time in the end, we find out. We had a hub and spoke topology. And this was possible because we had a huge amounts of fiber going everywhere. Fiber doesn't have much of a distance limit. Single mode with 1310 nanometer optics can go to 5 kilometers, 10 kilometers. So we happen to have all that available, which was a very large saver for this network. Copper is cheaper, copper is widely available, but there's a distance limit of 100 meters. So if you design your network based on having to put the switch every 100 meters, you end up with rings, you end up with very breakable links, you end up with many switches that have dual functions of both core and distribution and access, triple functions maybe. And if something breaks, then something breaks for a much larger area. If there's a loop somewhere and the switch dies because of that, because of high CPU usage, then it affects a lot more, and you may not be able to actually get there to isolate the problem. Splicing fibers on the field is possible, so we could actually run out a large network with fibers we did not order before, we just had lying around from previous events, and could therefore cut to size and customize completely. It does take a long time, especially if you have a bit older splicing kit, so the advice would be the next time to get a very advanced splicing kit with 3 cameras. Are you listening, Project Lightroom? The knowing about where people are going to camp is invaluable, because it allows you to plan your datum close, allows you to plan your fiber runs before actually people start camping right on top of where you want to run your fibers. And especially when we started expanding the network, as Lisa said before, into the camping area south of the south camping on the other side of the fence, we ran into some issues where people had put up their tents over the already dug trenches, and we had to dig new trenches to bury the fiber again to protect it. It is a bit of a challenge to get connectivity in outside major metropolitan areas. The Congress building had a versatile POP, had dark fiber that we could use. And here we had to spend significant effort to get a fiber in, spend significant money on that as well, and then arrange for connectivity on top of that, over that fiber, which also was a bit of a challenge. I'll talk more about that later. Every minute you prepare, you save here, and here is a stressy situation with a very clear deadline. If you have a bunch of servers you can pre-install and pre-configure, then you save so much time because you know it works, and you basically are up and running immediately. And this is especially important for network supporting services like DNS, DHCP, because without that, the network doesn't really work. You need a place to work from. Team members. It is important to not have too much bureaucracy. Sometimes egos get in the way, and people say, oh, this is my server and nobody else gets access to it, and then go to sleep for 12 hours or something while the thing is horribly broken. It didn't happen this time, but as a general design requirement for a network like this, it is important to remember that please check your big egos at the door and have fun. So more about the uplink. Up to about a week before the camp, we were still under the impression that we would have enough bandwidth, or at least a lot of bandwidth. A Gigi, dual Gigi, or an STM16. But a miscommunication between us and the two telcos involved in getting this line here meant that we would only be able to get an STM1. And after a lot of begging, we got some limited transit as well via a third ISP. And so managed to get about 300 megabits, 350 megabits of actual traffic off the campsite. So we hoped for more, but too bad. So we had an STM1 to Berlin. We had transit there from Cogent, peering with a few other companies in Berlin, NetSign, D-Hosting, who also gave us IPv6 transit. We hopped one hop over Telta's network to EWE-Tel, who gave us transit to here over GigE. The Berlin link first ran over the 2 ATM cards because we didn't have working POS interfaces for the 27200 routers. I think in the end it turned out that one of them was multi-mode, unlike what we were told. So when we replaced it, we got this email from our network monitoring system, oh, a multi-mode card was removed from the chassis. And we knew, that's why it didn't work. So removing the ATM, we did it halfway the Congress when we finally scored another POS card, packet over Sonnet card. And we could stop paying the 13% cell tax overhead for running a completely superfluous bit of ATM in our network. And we were all very happy to get rid of ATM. So, yeah, 300 megabits. Unfortunately, this time no separate IPv6 stats. We just didn't get around to setting up the service and the server for that and setting up all the monitoring for that. It basically flatlined the whole time. It's a bit of a pity, but we disabled incoming HTTP requests, incoming FTP requests, especially to the filers, just to save on some bandwidth and make it more available to the people actually here, able to enjoy it. So we ran into a couple of issues with the core router and other equipment. The most interesting one was these two guys. They had a Linksys, and whenever they connected it, it would run up the CPU of one of the line cards in our core router because it would start forwarding traffic in software. And they're shown here doing the only wise thing to a Linksys you can do to a Linksys, namely stringing it up and then flinging it away, although I don't think they actually did that. So I tried debugging the problem a little bit, and what we could see of it is that a lot of traffic actually went to the CPU that should have just flown through the hardware, and we are still in conversations with the supplier. I have to say that switching a gigabit in hardware really goes faster than switching a gigabit in software. So I was downloading something from the FTP server, and then I reseeded that line card, and suddenly the transfers went from 500 kilobytes per second to 10 megabytes per second. So there was a performance difference. I have no idea how a router can forget its own MAC address, but this is seemingly what happened when it's got like, oh, what is this? Let's handle it in the CPU. So possibly related to this is the fact that line cards a few times just randomly rebooted. We think this sort of coincides with this Linksys being connected to the network to a port behind module 2 actually. So module 6 crashing due to this is really, really strange to me. And like I said, we're still talking to a certain vendor about it. We made an offer for the Linksys to buy it because we thought we have to have this killing equipment. But it turns out that the owners of this Linksys are scientists, so they're not interested in money, and the negotiations continue. Also, problems that once we had some line card crashes, local switching stopped working. So the primary DNS server was unreachable for a while until we finally had enough of it and implemented the workaround, just connecting it to a separate catalyst, which just worked fine. Okay, I give the floor to Maxime for wireless.
Thanks. So it is a different story and difficult story, especially for me. I do it like over 3 years now, deploying the wireless networks at the congresses, and I see always big issues in RF and especially in the design of 802.11. So this year I decided to use trapeze networks. Aruba worked well, but there were quite some improvements to make. Trapeze sponsored us 2 controllers to run a redundant scenario. One of them crashed on the event due to hardware failure, so we had to replace it. They run basically QNX and were pretty stable if they are not hardware broken. So the vendor gave us 30 access points, MPRI 372, and basically they run Aphros radio interface. And they look like kind of a smoke alarm. Yeah, but besides that smoke alarm thingy, I think someone had fun about the whole day, about the whole event. Actually, they crashed quite often. But yeah. There was this other issue. It's again about a little bit the Verpeilungsfaktor. So what is wrong on this picture? Okay, the picture is bad. I will try to explain you. So this plug as a whole, this cable is also whole.
Like
the patch. I like my Clippy. Yeah, after we deployed Clippy into the antenna cable, still the access point decided after some time to switch from the external antenna to the internal antenna. So that's why RF sucked. So, oops. Okay, configuration. I decided to run location-based SSIDs, which were separated in 20 VLANs. So you had only one SSID where you could roam. You needed, therefore, to take a fixed IP address from the NOC help desk. But on the other VLANs, you got normally DHCP, but without roaming, because if you move from one area to the next, you get a new IP address and your SSH connection dies. 510 lines of config. We got the equipment 5 days before the event started, actually, and that was quite a lot of work. 3 people were involved. This means access lists, access point configurations, and yeah, VLAN interface configs. Interesting on this counter is 4,885 rogue access points. This count comes from the fact that we didn't start to try active defense or disallowing other users to connect to rogue access point, because, well, we should do that if our network is not running perfectly. So if you have a own access point which is like working in your area, it's okay. But next time we hope we get the right cables and we didn't have this RF issue. Yeah, this is coming basically from the fact that 802.11 management frames are unauthenticated, so everyone can spoof your connection or try to hijack you. So El Paqueto. So after some time, I recognized some kind of a strange packet broadcasted to every SSID VLAN. So I thought, what's happening here? After some while, I came through it. So assume that this here is your MAC address. Source 000, destination broadcast, IP protocol unknown. But here, you see 81.63.117.3. In the payload of this packet is the management IP address of my controller. And it was basically broadcasted all over the network. That's happened due to the fact that the access point generates this packet. If you join your network, that the controller knows where are you. It's just a forwarding update for the second controller due to redundancy stuff. Statistics, we had 320 users peak. That was a downtime. Megabytes in, about 16, out also total 34. Yeah, so that's it.
Hello? Say something? Oh. Sorry.
Thank you. Thank you.
Just two more things.
Two more things.
Just two more things. So, as I mentioned in the beginning already, we had a lot of help from volunteers here, from people helping at the NOC help desk, from various people joining the NOC team. They do that over and over again, and I don't understand why. And many, many others. And thanks to everybody who was helping out here. It was great, and we couldn't have done that without all the help we got. And, well, the next outdoor event is 2009, so if you want to join in, go ahead, and we see you 2009 in the Netherlands, I guess. And as always, end of connectivity, we're trying to turn on everything now.
So please be careful when you go home. Be careful with our equipment. It is not ours. It has to go back to all its respective owners. Try not to stand on the fibers still. We would like to reuse them for further events. And we'll try to keep some basic form of connectivity up for as long as we can manage to hold on to our equipment. As long as we don't have to pack it and everything. So thank you for your attention.
Thank you.
Now.